And if I drop the modeling clay into the beaker, it sinks to the bottom. If I now change its shape by flattening it out and making it into a kind of a bowl shape, and now place that in the beaker, we find that the plasticine floats rather than sinking. What have I done? All I've done is change the shape of it. Obviously now the plasticine is experiencing a different force that we call a buoyant force. It's being lifted up by the water. I have here just an ordinary piece of rock with a string tied around it so that I can connect it to my spring scale. When I lift it up and suspend it from the scale, the gravitational force acting on the rock is approximately 3.4 newtons. I'm now going to take that rock and lower it into a pop bottle with water in it. And notice that when I lower it, the water level goes up and my gravitational force decreases to about 2.3 newtons. Why the difference? The water itself is exerting an upward force on the rock as well. So I've got two forces acting on the rock currently. The string, which is pulling the rock up, as well as the buoyant force of the water, also lifting the rock. The buoyant force contributes at about 1.1 newtons. And the tension in the string decreases by that amount. The buoyant force is due to the displacement of the water. So notice then that as the stone is lowered into the water itself is displaced. The amount of water that's displaced, the mass of the water displaced, is equivalent to the decrease in the mass that we read on here. If I lower a piece of wood onto the surface of the water, the piece of wood floats. In this case, the buoyant force acting on the wood is greater than the gravitational force acting on the wood, and as a result, the piece of wood floats. It's independent of the size of the wood. If I take another piece of wood, a smaller piece of wood, and I place that on the water, it will float as well. It depends solely on the density, the relative densities of the wood and the liquid that I'm working with.